welcome all of you to yet another webinar hosted by Women of Suricata. And I'm Shivani, I'm a developer at OISF, and I shall be your host today along with my amazing coworker Juliana, who shall be giving you some updates about OISF and Suricon in a while. A little bit about today's webinar. This is kind of a special webinar because we host these webinars just once a year so far. This is a special webinar to showcase and celebrate the work that our Outreachy interns have been doing for past 3 months, and all that they have contributed and all that you can learn from their work and everything like that. So I'll give a brief introduction about the interns after Juliana has given you the updates about OISF and Suricon. Over to Juliana.
Hi again. So let me share my screen and hope things will be all right. I hope you can see my screen. So yep. Briefly, who are we? We are OISF, a 501 US non-profit organization mission to provide architecture and infrastructure to open source security software communities and to projects like Suricata, our main star. Funding comes from financial contributions from world-class security organizations using Suricata and using Suricata and committed to open source technologies. If you want to support Suricata and join our community, you can see our roadmap and at oisf.net. Contact us at info@oisf.net and connect with our community through our forum or with our Discord channel server. If you want to contribute, you can visit our webpage, suricata.io/features. You can support us through oisf.net. You can learn more about us with suricata.io or our forum.suricata.io, or with our documentation, which will be shared by our interns. And if you want, as I've mentioned, we have the Discord server, and if you are not there yet, you can email us at info@oisf.net for an invitation, or we'll also share the links. As you know, we yearly have our Suricata conference. This year, we are proud to announce that it will be in Athens in November 9, 10, 11, and call for talks and registration opens next week. So if you want to join us, if you have some interesting, cool talk you would like to give, do share it with us when you feel ready for that. And the webinar is being recorded, as I have already mentioned. It will be posted to our YouTube channel in a couple of days or so. If you have questions, you are free to use the Q&A chat. Shivani and I will be reading that by the end of the webinar. Or you can also ask questions in our Discord server, because then we can keep that living after the webinar as well. And as usual, thanks for being here. We are always happy to see you.
Thank you, Juliana. So we have two awesome ladies for speakers today with us. Our Outreachy interns, Modupe Falodun and Muhammed. They shall be giving you an overview about the Outreachy program, how you can apply, and how you could also apply to be with us, and all the work that they have been doing, and how you can add on to their work or contribute in a similar manner, because the work that they have been doing is something that you can also do in different parts of the code. So both of them have amazing intros lined up in their own presentations. So I would refrain from spilling the beans about them because they have really good stuff to say. And I think I would give the stage over to Modupe now, who shall be starting her presentation. Modupe, the stage is yours. Please share your screen.
Hi, thank you, Shivani. Thank you, Juliana. Okay. I believe you can see my screen.
Yep, perfect.
Yep.
Okay, awesome. Hello, everyone. My name is Modupe Falodun. I am an Outreachy intern with OISF working on Suricata. I will be talking about improving Suricata QA by Suricata-Verify. So a bit about me. I am a Nigerian. I live in Lagos, Nigeria. And before OISF, before becoming an Outreachy intern, I had 1 year experience as a software developer where I enjoyed building applications for the backend for applications using tools like JavaScript, Node.js, and databases. In my free time, I enjoy reading novels. I love traveling, and I also love volunteering. You can find me volunteering at the Seed Initiative Nigeria. I also love contributing to open source, and Outreachy was a very good avenue for me to start my journey to contributing to open source. Also, you might find me or you might catch me learning French in my free time. So I also love learning new languages. I've started with French, and I hope that very soon I'll be able to move on to other languages. Before joining as an Outreachy intern, I had no knowledge about InfoSec or cybersecurity. However, based on my experience as an intern, I would love to learn more about cybersecurity and how I can connect my experience as a developer with cybersecurity. So what is Outreachy? It's a program that provides an opportunity for underrepresented people in the world to contribute to free and open source software. So it's 3 months and it's a paid internship. And if you like to know more about Outreachy or apply to Outreachy, you can apply at outreachy.org. I think there is an application. I believe there's an application going on currently, which will be ending tomorrow, 25th of February. So you can apply to Outreachy at outreachy.org. So Outreachy has 3 stages, which is the initial application period, which is currently running, and it runs twice a year. And then after the initial application period, then there's a contribution period, which spans for a month. There you get to interact with different communities and projects and pick a project pick a project that you would love to work with. And then after that comes the internship period. So based on my contribution experience, I would be sharing some tips that I believe would help future applicants or current applicants to Outreachy. So first off, I would say that it's important to have a goal when applying to Outreachy. Understanding what you would like to gain out of the program would help you to pick the community that you would want to contribute to. And I always say that it's a two-way thing. So it's important to know what the community requires from an intern. There are some communities that require certain skills or expertise in certain languages or certain skills, and it's important to know if this aligns with your learning goals or your current skills, and that would help you to know if you would be a good fit for the community and if there would be a good fit for you too. Also, it's important to focus on submitting quality PRs, so understand the tasks that you have been assigned and understand what your mentors expect from you, and always ask questions when you're stuck. So if you would like to know more about my Outreachy journey, I blogged a bit about it at thecalisi.wordpress.com. You can read my blog to know more about my Outreachy journey. Next, why did I choose Outreachy and why OISF? So for me, I've been wanting to contribute to open source for the longest time, and Outreachy, if you're a beginner to open source, you would know that there are a lot of projects, and sometimes it's very hard to know what project that you would want to contribute to. Sometimes it's hard to approach these communities and say, oh, you want to contribute to them. So Outreachy creates a safe space for you to connect with open source communities. And that for me was the reason why I applied to the Outreachy program. And it's also a great opportunity to network with people all over the world. For OISF, OISF is a warm community which has a great culture, and I've met amazing people at OISF. I met amazing people at OISF during my contribution period, and that for me was the main reason why I chose OISF. It was also because I had the opportunity during my contribution period to learn something new. I started working with Rust, and I was able to start contributing almost immediately with zero knowledge of Rust beforehand. So also the opportunity to work on an amazing project like Suricata, which you'll be learning more about shortly. So Suricata, what is Suricata? So Suricata is a software that deals with intrusion detection. It also deals with intrusion prevention and network monitoring. My fellow intern, Sam, will be talking more about Suricata and will be giving you details about how amazing the software is and what you can use it for. So for every application, it's important to have tests. As a developer, it's important to write tests for an application that you're contributing to or you're developing. And this is because for a large application, you're constantly making changes and adding new features. And if adding a new feature to the application could affect another part of the application, right? So it's important to have tests to ensure that you automate checking that a new feature does not affect another feature. So Suricata-Verify for Suricata is the tool, it's a Python tool that does this for Suricata. It is a part of the Suricata QA that developers use to test new features of Suricata. And it has Suricata-Verify tests that run Suricata with specific configuration and verify the output. So you can learn more about Suricata-Verify, and if you would like to contribute to Suricata-Verify too, this is a link to the Suricata-Verify GitHub page. So I'll be talking about my Outreachy project next. The overall goal of my Outreachy project was to improve Suricata QA by converting complex unit tests from Suricata to Suricata-Verify, and also by cleaning up Suricata tests. So this is an example of the impact of my project on deleted lines in Suricata. So Suricata is moving to Rust, and it's important to reduce the number of lines of C tests, especially the ones that can be converted to Suricata-Verify. So as you can see here, for this particular test, detect URI content, over 1,000 lines of code were removed from the C side, and this test have been converted to Suricata-Verify. Now, this also has removed over 1,000 lines of code, which have been converted to Suricata-Verify. So this is just an example of two of the tests that I've worked on that have removed tests from Suricata and converted this to Suricata-Verify. So what is the general process of converting tests to Suricata-Verify? So if you love to contribute to Suricata-Verify and convert tests to Suricata-Verify, the first thing to do is to find a test that needs conversion. And how do you know a test that needs conversion? Any test that is complex, that is doing several things in one, is a test that is a good candidate for conversion. And I'll be showing you an example of that shortly. Secondly, is to understand the goal of the test. And to understand the goal of the test, you need to check the rule of each test and research the keyword, the keyword in each rule. So I'll also be showing a demo of how to check the rules of the test and understanding what a Suricata rule looks like. Then you proceed to create a test using the create_test.py method. So create_test.py is a Python script that is used to automate the creation of Suricata-Verify tests. And then you can run your tests to ensure that it's creating the outputs, it's generating the output that you're expecting using the run.py method. So run.py is a Suricata-Verify script, the Python script that is used to run all Suricata-Verify tests. And you can also use it to run specific Suricata-Verify tests based on their patterns. So this is an example of a complex Suricata test. And here, this particular test is doing a lot of things at the same time. It is doing signature passing, it is doing error handling, and it's also doing alerting, checking for packet alerts. So this is an example of a complex test that needs to be converted to Suricata-Verify. And I'm going to be showing you an example of a simple test. So this is an example of a simple test. This test is doing just signature passing, and this is what we want the test in Suricata to look like. So this is a demo of how to check for keywords on Suricata documentation. So if you can see, you can go to suricata.readydocs.io to check the documentation, and you can learn more about Suricata with this documentation. Here you can see we're checking for URI content, and this shows us what we expect the rule to match against once we have that keyword in our rule. So this is just a visual representation of the general process of converting to Suricata-Verify. You need to ask yourself, what test needs to be converted? What is this test doing? What rules are in the test? What do the keywords in the rules mean? And then you can proceed to create your test and run your test. However, for my project, because I was working with tests that had to do with detection, my process for converting tests to Suricata-Verify was slightly different. So for me, after checking the rule of the test and researching the keyword, I would then need to find a suitable packet capture or create one using Scapy. Scapy is a Python tool that helps us to interact with packets. So after creating a packet or finding a packet capture, I would then proceed to create a test using the create test.py method. And I'll be showing a small demo of how to create a test using create test.py method shortly, so you can have a visual representation of what it looks like. Then I run my test using run.py. So after doing that, I will create a Suricata-Verify PR, and then remove the converted test from Suricata, because after a test has been converted to Suricata-Verify, it's important to remove them from Suricata. And then I convert whatever test is remaining to use the fail or pass API and create a corresponding Suricata PR. So I talked a lot about Suricata rule and understanding the rule and what it does. So I would be talking about how to understand a rule, or what a Suricata rule looks like. So Suricata rules are also called signatures. So I'll be using signatures and rules interchangeably during the course of this presentation. So it's divided into three parts, which is the action, the others, and the options. And the action is what tells Suricata what happens or what Suricata should do when the packet matches the rule. It's usually the first part of the rule, and it could be alert. So you're telling Suricata to generate an alert when it finds the packet that matches the rule, or it could be drop, pass, or reject. Next is the header. As you can see here, this is a visual representation of what the header looks like. It describes the network protocol that Suricata should match against, which could be TCP, IP, UDP, or a few other application layer protocols. This is the source IP and the source port. It also contains the direction, which could tell Suricata to match both ways or in one way. And then it contains the destination IP and the destination ports, which allows Suricata to filter based on the IP of the port. Next is the option, which matches data contained in the packet. So I'll be showing you a visual representation of what a Suricata rule looks like, and I'll be explaining that. An option usually contains a signature ID, and that is how we identify the rule that triggered that particular alert. So this is what a Suricata rule looks like. And as you can see here, this is the action. This first part is the action, which tells Suricata to generate an alert when this particular, when a packet with these particular filters is found. And this is the header, which has the protocol, the IP, the source IP and port, the direction, as you can see, and the destination IP and port. This is the keyword here, which is saying to set flow bits, and it's giving it a name of FP1. And this is the signature ID, which is 1. So I talked about creating a packet with Scapy, and this is a visual representation of what a script to create a packet with Scapy looks like. Now, the create test of pi method. The create test of pi method, like I said earlier, helps us to create tests with Suricata-Verify. It's an automated way of creating tests. So it has several parameters or arguments, which is the test name, the pcap file, that's the part of the pcap file, and the output part where you would want your test to be generated. And then this event type only and allow events are, you either use event type only or allow events. So event type only says that, tells Suricata-Verify to create filters based on only event types, and allow events allows you to tell Suricata-Verify to filter based on specific events. So I would be showing a demo. This is a demo of how we can create a test with Suricata-Verify. So first off, you need to make sure that you are in a Suricata directory, valid Suricata directory. And as you can see here, I'm using the create test.py method. And then this is the path to the role. And this is the output part, which is Suricata-Verify/test. So here I'm telling Suricata to filter based on events only. And this is the name of my test and the path to my pickup. This says that your test has been created. So let's go into the Suricata-Verify directory to look at what our test looks like. So this is what our rule looks like, the rule we use for this particular test. And as you can see, this is supposed to create an alert against any SSH protocol. And this is what the signature ID looks like. So let's look at the test.yaml to look at how many alerts were created. Wow, so 2 alerts were created from this test. And we will be looking at our if.json to see the signatures, that the particular rules that created the alert. So here we can see that signature ID 2 and 4 generated an alert for this particular test. You can also add filters for those particular signatures in your test.yaml to ensure that every time this test is run, only those signatures generate those particular alerts. So this is also a way of creating tests using the allow events. So this is just telling Suricata-Verify to filter based on certain events. And if you see on this, in this particular test, we are filtering based on alert and SSH only. Excuse me. So this is also another way of creating tests with Suricata-Verify. And then next, after creating your test, you would want to run your test to ensure that it is generating the outputs that you're expecting. So you can run your test using the run.py method. And here we are running test based on pattern. So this particular test is running all tests that have the pattern of host bits. So this is a way to run Suricata-Verify tests based on a pattern. I think I already have, okay, yes. So also while running Suricata-Verify tests, it's important to run from a valid Suricata directory. And here in this particular demo, you can see that we are running all our Suricata-Verify tests. So without the pattern, Suricata-Verify would run all your tests. And this is what it looks like. So what are the tools and resources I found useful during my internship? First off, Wireshark for analyzing packets, because I had to create packets or look for packets that would generate an alert. I had to use Wireshark for analyzing those packets. And a tool that was very useful for me, or a resource that was very useful for me to understand how to use Wireshark for packet analysis was this website, malware-traffic-analysis.net, which is very beginner friendly and would help you if you're just learning how to analyze packets with Wireshark. Another tool that I mentioned earlier is Scapy, which is a Python tool for manipulating packets. So you can read more about Scapy on scapy.docs.io to learn more about how to use Scapy to generate packets. Very important is the Suricata documentation, which I mentioned earlier, which will help you to understand the tests and the keywords, and also just help you understand how Suricata works. So this is what Wireshark looks like, and this is what a packet in Wireshark looks like. So what have I learned? I believe that one slide is not enough to contain everything I've learned during this internship. However, there are some important things I would love to mention, which is the opportunity to connect with people from different environments and different backgrounds, and basically just learn a lot from them. And also to work in a remote, very warm and welcoming team is something that I'm very grateful for. I've also added more songs to my playlist based on what my mentors or my fellow interns introduced me to. And here I would love to give a shout out to my mentors, Shivani, Juliana, Jason, and Victor, and also to my fellow interns, Sam, for being supportive throughout this journey. Thank you so much. For the technical part, I've learned a lot about Suricata and Suricata-Verify, coming from someone who did not know anything about Suricata and did not know anything about InfoSec or Rust or any of those tools that I've used so far. This is a big jump. It's a lot to having a webinar where I talk about these tools. I also learned how to use Scapy to generate packets. I learned a lot about network protocols and its importance in information security. And during my contribution period, I worked with a bit of Rust, which I had to learn, and I hope that I would be able to build more projects on it or build on that knowledge. So what next after Outreachy? For me, I would love to keep contributing to Suricata, and I love contributing to open source projects. So I would love to find more open source projects to contribute to, and hopefully inspire more people to contribute to open source projects. I do hope that my journey, my Outreachy journey, and my journey to interning as an Outreachy intern with OISF would encourage more people to apply to Outreachy and to basically put themselves out there and understand that they can also contribute to open source. Thank you so much for watching my presentation. If you'd love to learn more about my work with Suricata and Suricata-Verify, you can reach out to me on LinkedIn. My name is Modupe Falodun on LinkedIn. My email address is falodunmudupeola@gmail.com. And if you would love to learn more about the work I've done or the work I'm currently doing on Suricata and Suricata-Verify, you can check my GitHub page, which is at the Kalisi. You would also see some of my personal projects that I've done there. You can also reach out to me if you have any open source projects that you would love me to contribute to, or you would love us to work together on. Thank you once again for watching my presentation. And I think if you have any questions, you can drop it in the chat. Thank you.
Thank you, Modupe. Great presentation. And yes, anyone, if you have any questions, please drop them in the chat or Q&A. We'll a lot of compliment showering for you, Modupe. I'll tell that. I should probably tell that as well in the end. But great job. Thank you. And please post your questions in the Q&A or chat. We'll be monitoring both of them. And compliments, Modupe. Okay, thank you very much. Let's give the floor to Sam now. Sam, please show yourself. And the floor is yours. Your slides can be shared.
Thank you all. Great work, Modupe. Okay. Let's share my screen. Thanks again for being here. Today I will be talking about my project as an Outreachy intern with OISF for the past 3 months. I've had a great time. I'll be talking about adding frame support to specific protocols. This is part of Suricata 7.0, the latest version on master. I am Sam Muhammed. I'm an information security enthusiast. I've been doing this for more or less a year, so I'm pretty much a newbie. I'm mainly interested in reverse engineering of malware. Through time, I have developed this interest for not only trying to dissect malware and expose their injection techniques or the lots of stuff that you could do and tinker with system internals. I have developed this interest for adversary emulation. So most of the times I learn about a new technique, I go about implementing the technique. And yeah, it was fun having the two perspectives of the defensive side, reverse engineering a sample, and the offensive side of let's try to re-implement that, giving stealth to red team operations. You can check my blogs. I do technical blogging, a bit of what I have encountered. The first blog here is basically a walkthrough of the samples that I have worked with. The second blog is me basically learning about system internals, because this is what has derived me to this field in particular, system internals. And of course, specifically Windows, because it's a huge playground for malware, right? With that said, I was thrilled to see the Suricata projects on Outreachy project list. I came across Outreachy, I think 2 years ago. I don't remember how, but I'm glad I did. I also blogged about my journey so far in the WordPress blog. You can check it out. So yeah, I'd have to assume that some of you might not know about Suricata. I will basically give a gentle introduction to the solution. Suricata is a network security monitoring system. It's an industry-leading solution. If you want to know more about the project, trying it out, you can check the blogs at suricata.read.docs. The user guide, it will walk you through the installation, how to use it, the different modes that you could set up Suricata based on your needs. And what's great about Suricata as an open source solution is that you can pretty much integrate it with your own projects. So basically, for example, the Eve box project is a web interface that would provide a user-friendly interface for threat hunters and rule writers to interact with events and alerts. It was developed by my mentor, Jason Ish. There's also this full-blown solution that you can set up in your system for your SOC team, the SELCS project. It integrates Suricata with a bunch of other open source tools and community edition tools to give you this full-blown network security monitoring system. It is developed by the Stamus Networks. And also, for example, any.run is a famous sandbox. If you're into information security on malware, probably there's a big chance you know of the any.run sandbox. It released a blog on how it chose Suricata IDS as part of its system. I also advise you to get involved with the community. They have the discourse forum and a Discord server, as my mentor Juliana has mentioned. In the discourse forum, you'd probably get a lot of blogs and resources and educational stuff there. So there's a good amount of educational knowledge that you can get out of the discourse forum. Also, the Discord server will have a bunch of announcements for incoming webinars and important events. I've had the chance to attend a couple of them as an outreach intern. If you want to get even deeper, you could go for the trainings and courses. They have the OISF-Suricata YouTube channel with all of the webinars and important trainings. I think this webinar will be uploaded there. And there is also a Pluralsight training that's made by the OISF team. Shout out to Josh Stroshine, the director of training. Again, if you're into InfoSec, there's a big chance you know of him. His content has helped me a lot, even before Suricata. So for contributing to Suricata, do we need to know all of this? No. You can pretty much start with the guide. They have the guide of how to get started contributing to Suricata. And what's important is that we are developers, right? So it's important to know the guidelines, especially for the code and following the code style and convention. So this will make things more organized and neat, as Modupe sort of mentioned. Also, the community guidelines are important. For example, these are a bunch of issues that you could start with as someone who is new to contributing to Suricata. They are always labeled as good first issues. And also reach out to the team. They will help you getting assigned to specific tasks based on your skill set. So let's get to my project. As I sort of mentioned, adding the frame support feature was the work that I was supposed to do. The feature itself was developed by my mentor, Victor Julian. I've added a link to a blog talking about the frame support feature because I might not have much time going into much details. But basically, the overall view of adding the frame support feature to a protocol is that, let's think of it of what will the feature give us. For rule writers and threat hunters, what we care about is writing concise rules and match on specific contents. So for these two screenshots, for example, the first one is 2 rules and somewhat a shrinked output of logs for NFS and with and without the frames. I will take NFS as an example because this was the protocol that I was working on. So in this example for the logs, we see here that we have a bunch of different frame types. I'll be talking about those later on that are being logged out precisely. So we have this payload that exists in this frame. And for the alerts, it's a more somewhat precise alert because you tell the detection engine exactly where do you want to match this content on. So this will get us back to the work of detection. Prior to the frames, the detection engine has this full stream of data, and if we have alerts that we want to match some signatures on, the detection engine will process the stream and then we'll go and look back, oh, do we have a rule for some protocol? Again, for example, let's take NFS. Do we have NFS contents in this stream? And if we do, we match the rule on. This is lots of work. And what the frames does, as I will go through later on, what the frames does is that we tag a couple of frames while we parse the protocol traffic. And by tagging these frames, we basically tell the detection engine that if you have some rules for this specific protocol, these are the places that you could go and look for to match and do your detection work. So for performance, this is pretty much less work being done by detection work. And yeah, so basically what we have is better rule writing, better logging, and better performance. So as I sort of mentioned, adding a feature to a pre-existing code, I thought that was not very approachable to start with, because I had to know what this code is doing exactly. So I took some time to, since I was assigned to add a feature to NFS, I took some time to go through the protocol. And for protocol decoders, what's being done is that we process the traffic and we parse different records of the traffic. And for NFS, there are 3 versions. We have 2 and 3 and 4. So we go and process the traffic and parse each record for each NFS version. What was missing was unit tests to test for the successfulness of the parsers. So I thought that's an approachable task to start with. And as you see here in the screenshot on the left side, we have 3 functions. Each one of them is parsing a specific record: request lookup, request read, reply read. So each one of them uses non-parsers. And non-parsers are basically these small parsers that parse data with any type. So for the first parser, we have a couple of fields that we parse, and then we return the fields that we care about. There's also some considerations about what we return from a parser function that parses record. What do we care about this record? So what I had to do is to write unit tests. This is what Modupe has been working on, is to write unit tests over each parser of those to confirm that the parser is successful with respect to the number of fields in a record, the offset and sizes, and all these other factors. So by writing unit tests for all the parsers, we now are sure that we are parsing the traffic correctly. And for that, I had to use Wireshark. I think their slogan was somewhat like dive deep or go deep, something like that. So I used Wireshark to dive deep into their records. What I had to do was basically take some real data and use the parsers to match and see if the parser is parsing all of the fields correctly, again, with respect to the offset and sizes. And we can also have like common fields. For example, this file handle field is pretty much all over NFS. So having a small parser that parses this field, we can use it with all the other records that uses this field. So this is an example of a unit test. What I do is take some real data and then go check if the parser is parsing everything correctly. Right, so what are the skills that I have learned from writing unit tests? Basically Rust. This was my first time programming in Rust. And of course, NFS protocol specifications, because I had to make sure that I understand the records and to be able to do the work. So of course, Wireshark and CyberChef. CyberChef is a great tool for converting data two different types. So I've been using CyberChef to convert hex to decimal to base 64, ASCII, what have you, because all of these data formats are being used to match against the parsed fields. So I thought that, okay, this is enough. I think I should work on adding the frame support. I now have somewhat a relationship with NFS. So when I first approached this, adding the frame support for NFS, I thought I'd need to know more about the components of having a protocol parser. And basically one thing that has helped me was a webinar by my mentor, Juliana, when she was an outreach intern. I think that was last year. So her work was about adding support for a new protocol to Suricata. And she gave me the basic skeleton for what a protocol support consists of. So now I could be able and read through NFS and know what it is doing exactly, know where do I need to put my changes over. So for the frames itself, for the process of adding frame support, you basically go through 3 to 4 steps. You start with knowing exactly what are the frames that you need. And this is based on some considerations. Of course, this is per protocol process. So of course, the protocol specifications is number 1, but then you think of, you consider detection. Is this data important for detection or not? And based on that, you create frames. For the frame types, basically there is a naming convention for the frames. So at least you would need a PDU, a header and data. If your protocol specification decides something else, you go about making frames for the needed data. But basically, what we at least should care about is a PDU, data, and header. And then after making sure that you have the right frames, you go about registering the frames using the frames.rs API. And what this basically does is pointing out to the detection engine that if you need to do some detection work over a stream of NFS, these are the places where you should look at. For example, these 2 functions here are the registration frames for the RPC records, the RPC frames. And then after that, you tag the frames. This is done. This will get us back to the very objective of the frame support, which is to be able for application layer parsers to tag frames while processing. So these frames could be used by the detection engine if there are rules to match against. So while parsing, you go and tag the frames. And as I sort of mentioned, we basically at least care about the PDU. So this could be tagged even if we're not successful, if the parsing will be complete. And then for the inner frames, you go about tagging those when you're sure that the parsing will be successful. So after that, this is to showcase the changes that you've made. And basically you do that by testing for the logging and detection. Has the frames reflected on detection and logging? For example, these are 3 rules that wants the detection engine to match against this content and specifying the frames that you would find this content in. And these are 3 checks. These basically tests for the log output that, for example, we have a 31 record that has a frame of type rpc.crits. So this is how you would test for your frames outputs with respect to detection and logging. So yeah, what have I learned after making the frame support feature? Plus everything that I've done with unit tests, I've learned more Rust and of course more NFS protocol specifications, especially what's needed for detection. I've learned much more about the implementing a protocol support in general. What are the main components of protocol support? I had the chance to write some rules and SV tests. Also, if you want to, I know that this is somewhat a very brief idea about the feature, but if you want to get in deep and go in details of how to add frame support to a specific protocol, please check this guide. It's very detailed and giving references to protocols that are already has frame support in the latest Suricata release. Yeah, fun fact. I have realized that I have spent somewhat a good time with NFS, that I would wake up someday and, oh, okay, this is the output that I expected. But then other moments I was like, no, something is wrong here. So I was able to spot some anomalies, especially with adding unit tests, because as I sort of mentioned, unit tests makes sure that your parser is doing what's expected, is parsing the records successfully. And for NFS 4, because it's somewhat a distinguished and different, it has a distinguished and different formats from NFS 2 and 3. NFS 4 has this compound record that has a bunch of operations inside. So for a compound request or a compound response, what we have is a bigger parser that basically parses the compound record. If it goes through all of the operation opcodes and tests and checks if we have parsers for each operation. If we do have a parser for each operation, the parsing will be successful and will consume all of the data, right? But if there's an operation that doesn't have a parser, the parsing will fail. So as I went for making an SV test for writing unit tests for NFS4, I found a bunch of malformed data that were being logged. So based on the advice of my mentor, I went about debugging the thing, and then I found this code switch, and I was like, okay, I came across this code, this error code before, and that led me back to the compound records, because some operations were missing some parsers, and because of that, the compound record itself will not be parsed successfully. So I had the chance to add some parsers for the missing operations, and yeah, that was pretty much fun. I have realized that I have spent so much time with NFS to this extent. So yeah, I hope this was informative for you. If you have any questions, I'll be glad if I could answer any. And of course, there is also the discourse forum. If you have any questions that you'd like to ask, the OISF team will help you there. These are my contacts. If you want to ask me any questions about my journey in general as an outreach intern, I'd be happy to answer those. Yeah, so have fun and learn in these crazy times. So yeah, thank you. And if there are any questions, I'll be glad to answer. Giving it back to you, Juliana.
Great job, Sam. Thank you very much. And compliments pouring in for you as well. I do not spot any questions in the Q&A. Have there been any on the chat, Juliana?
No, I didn't see any. I did recommend this webinar to anyone interested in interning with us through Outreachy or anything else. So you might get future questions, some in Modupe, because, you know, we have future rounds coming, so that's something possible to happen. Thanks a lot to everyone who's been with us today, this afternoon, evening, morning. As you know, we try to have monthly webinars, so do follow us on Twitter, also on Eventbrite, because usually we have our events announced there, and you'll be able to know of any news. I've learned that we will have some interesting things coming on in more of a hands-on style starting on March. So yeah, keep posted. New hands-on exercises and other things like that will be showing up soon. And as you know, we have all those links that were nicely shared by Modupe and Sam, and which are very useful to anyone interested in getting started or advancing their already existing knowledge, all of that. Thanks a lot for being here once again, and in a couple of days you will see this on YouTube as well. So if you can, and if you want, you can share it. I think that's it. Do we want to say anything else, folks? Don't leave me alone. I don't want to sing again.
Great job, ladies. Well done. Thanks everybody for being here.
Thank you, everyone, for